Honda's philosophy can be summed up in these words: a company without dreams will lose its place in society. Honda has never been shy about dreaming, nor about turning its dreams into reality. In the 1960s, early in the company's history, Honda engineers saw the possibility of effectively controlling exhaust emissions by focusing on the combustion process. Their dream led to the development of the CVCC engine, a low-pollution, high-fuel economy technology. In 1974, in the wake of the first OPEC oil embargo and at the dawn of the environmental movement, the Honda CVCC Civic was introduced. It was the first and only automobile to meet the new Clean Air Act standards without using a catalytic converter and while running on regular gasoline. It was a vehicle that pioneered Honda's ability to produce high fuel economy, low emissions automobiles. Ever since, Honda has been an industry leader in designing fuel-efficient cars. Indeed, every year since the EPA began publishing the now familiar city and highway fuel economy numbers, Honda vehicles have ranked among the top 10 mileage leaders. In 1986, the CRX HF became the first car to break the 50 mile per gallon barrier. Advanced engine technology continues to be at the heart of every Honda breakthrough. Honda is the largest engine maker in the world, producing more than 10 million automotive, motorcycle, marine, and power equipment engines annually. Honda's engine expertise is also in evidence on racetracks around the world, with a history of championships in motorcycle, Formula One, and Champ Car racing. Pushing engine technology to its limits is what makes Honda engines so efficient, and efficiency is what makes them ever cleaner. In 1995, Honda introduced a new Civic, which was the first vehicle to ever meet California's low-emission vehicle standard, and the first ultra-low emission vehicle was the 1998 Accord. Today, Honda voluntarily sells low-emission vehicles nationwide. For the 2000 model year, about 85% of Honda vehicles sold in the U.S. meet or exceed these standards. Honda has also been at the forefront of new and alternative fuel technologies. The first four-passenger electric vehicle with advanced nickel metal hydride batteries was the Honda EV Plus. And the world's cleanest internal combustion engine vehicle is the Civic GX, a dedicated natural gas vehicle. The GX produces 98% fewer hydrocarbons and 26% less greenhouse gases than today's typical cars. Honda has also announced plans to put a fuel cell vehicle on the road by 2003. Now, a quarter century after the dream of the CVCC Civic was realized, the ultimate statement of Honda technology, the new Honda Insight, is about to be born. The all-new Honda Insight is a statement of advanced Honda technology in every aspect of its design and execution. It takes the combination of efficiency, emissions, and safety to new levels, using revolutionary new powertrain technology, advanced lightweight materials, low-friction designs, and Honda's new G-Force Control safety technology. The Insight achieves the highest fuel economy in the world for a mass-produced, gasoline-fueled, internal combustion engine vehicle. It has one of the most aerodynamic bodies of any vehicle on the market today. It achieves both ultra-high fuel economy and ultra-low emissions. And when it goes on sale this December, It will be the first gasoline-electric hybrid vehicle in the United States. At the heart of the Insight is Honda's Integrated Motor Assist, or IMA system. The principle behind the IMA system is simple. The greatest demands on horsepower and torque come while accelerating and climbing grades. On a level road, at cruising speed, minimal power is needed to maintain a vehicle's speed. By using an electric motor to provide a power boost to the engine when appropriate, a smaller, more fuel-efficient gasoline engine can be used. The Insight's 67 horsepower VTEC E engine is the lightest 1-liter engine in a production passenger car today. This 3-cylinder 12-valve 1-liter engine produces 66 foot-pounds of torque at 4,800 RPM. But with Honda's Integrated Motor Assist, it achieves a maximum of 73 horsepower, providing performance comparable to a 1.5-liter car. Honda engineers aim to reduce both weight and friction while designing this engine. Lightweight plastics are used for the water pump pulley, the valve cover, and the intake manifold. The oil pan and the ECU case are made of magnesium. The Insight engine also features an offset cylinder design, with the cylinder bore offset 14 millimeters from the crankshaft center. By doing so, maximum combustion pressure occurs at a point where the connecting rod is straight up and down in the cylinder. This means that there is minimal lateral force in the cylinder walls, thereby reducing internal friction by as much as 3% and improving efficiency. A compact spherical combustion chamber increases swirl ratio, and a narrow angle between valves also helps to increase combustion efficiency. The engine operates at a high 10.8 to 1 compression ratio. The connecting rods are carburized steel, which increases fatigue strength by 50% and reduces weight by 25% compared with conventional steel connecting rods. The VTEC E system employs L-shaped roller-type rocker arms on a single rocker shaft. At low RPMs, only one intake valve per cylinder is in operation to minimize fuel consumption. To gain power at higher engine speeds, the VTEC E system engages all 4 valves on each cylinder. As a further aid to reduce friction, the pistons have been given a surface treatment to enhance oil film performance. The Insight features a direct ignition system. A unique spark plug features an iridium tip and is designed to keep the electrode aligned in the cylinder head for optimum combustion efficiency. The cylinder head is integrated with the exhaust manifold for faster catalyst activation, which helps reduce emissions. It also allows for manufacturing efficiency, reduced weight, and a more compact engine size. But the Insight does not sacrifice performance. The additional torque and performance boost comes from an ultra-thin, lightweight DC brushless motor. This 10-kilowatt motor, which is just 60 millimeters or about 2 1/3 inches wide, sits between the engine and the transmission and is connected directly to the engine's crankshaft. It supplies up to an additional 36 foot-pounds of torque during acceleration and acts as a generator during deceleration to recharge the IMA battery pack stored in the rear of the car. In addition, Honda engineers developed a way to use the electric motor mounted to the engine's crankshaft to smooth engine idle vibration. Honda adopted advanced nickel metal hydride batteries, which it pioneered on the EV Plus electric vehicle. For the Insight, 20 modules, each containing 6 1.2-volt cells, supply 144 volts. The battery pack weighs only about 48 pounds. The battery pack is contained in the IPU, or Intelligent Power Unit. The IPU also contains the control modules for the battery and motor, the inverter, and the DC-DC converter. It also houses cooling systems for the power electronics and battery. The Battery Control Module, or BCM, continuously monitors the condition of the battery pack. Sensors for voltage, battery temperature, and other functions provide input to the BCM. The IPU maintains battery operating conditions within an optimal range. thereby ensuring long life for the nickel metal hydride batteries. The IMA system has 5 operating modes: startup, acceleration, cruising, deceleration, and idle stop. At engine start, the motor control module sends a command to spin the motor at 1000 RPM to start the engine. Using the integrated motor assist to start the engine results in a smooth, quick start. Under acceleration, the motor control module monitors the load on the engine and provides electric motor assist when appropriate. While cruising, the function of the IMA depends on the IMA battery state of charge and the load conditions of the engine. Under high load conditions, such as climbing a steep grade, the motor control module can provide an assist from the electric motor for improved efficiency. During deceleration, some of the energy of the vehicle's forward momentum and braking is converted to electrical energy to recharge the battery. In this way, energy is conserved and the vehicle operates more efficiently. Finally, the IMA helps conserve fuel by turning off the gasoline engine when the vehicle comes to a stop. Drivers will notice the tachometer drop to 0 and the green auto stop indicator light come on as they come to a stop and shift into neutral. As soon as the clutch is depressed and the transmission shifted out of neutral, the electric motor restarts the engine. The restart by the IMA system is so rapid that there's no perceptible delay, and the engine will be running by the time the driver has shifted into gear. The idle stop feature operates to help conserve fuel. In certain situations, such as low battery charge, or if the engine is not warmed up, idle stop will not engage. If the transmission has not been shifted out of first gear since the last stop, the engine will keep running to prevent frequent idle stops in slow-moving traffic. If the automatic air conditioning system is on, the IMA system will also keep the engine running in order to keep the air conditioning compressor operating and maintain a comfortable cabin temperature. However, idle stop will periodically engage if the economy mode has been selected. As a safety feature, a warning will sound if the driver's door is opened while in idle stop mode. By providing additional torque, the IMA allows the internal combustion engine to operate more efficiently, and it allows for a smaller displacement engine than would otherwise be possible. The high fuel economy that is possible with a smaller displacement engine not only conserves natural resources, it also helps to reduce greenhouse gases, the production of which is directly related to fuel consumption. The Insight's engine is designed to operate at a very high air-fuel ratio, up to about 22:1. But while lean air-fuel ratios improve fuel economy, they can limit the catalyst's reduction of certain emissions. Therefore, to ensure that the Honda Insight achieves ultra-low emission levels, Honda developed a new NOx catalyst. During lean burn conditions, NOx molecules are attracted to and held by the catalyst surface. When the engine is operating with a normal air-fuel mixture, the catalyst removes the oxygen from the NOx molecules and oxidizes the hydrocarbons and carbon monoxide remaining in the exhaust to form water vapor, carbon dioxide, and nitrogen. This allows the Insight to meet the ULEV standard, reducing hydrocarbon emissions by 84% and NOx emissions by 50% compared to a typical car. Another benefit of the Insight's high fuel economy is its extended driving range, about 600 to 700 miles on its 10.6-gallon tank. The Insight is equipped with a molded plastic fuel tank, another weight-saving feature. The Insight's 5-speed manual transmission is an all-new design exclusively for this vehicle. It is both lightweight and compact, weighing just 91 pounds, more than 9 pounds less than the current Civic 5-speed transmission. The transmission gears have been carefully machined to reduce rotational mass. The lubrication system has been optimized to provide more efficient lubrication with less oil, saving weight and size. The transmission also incorporates a neutral switch to tell the IMA system when to engage the idle stop feature. Advances in engine design and powertrain systems, along with Honda's revolutionary integrated motor assist, are but one leg of the technology used to achieve the Insight's goals. The second leg of the technology is the lightweight aerodynamic body that achieves a high degree of rigidity and world-class occupant protection. The choice of aluminum for the Insight's skeleton and major body panels was driven by the desire to reduce weight. Since its weight is just one-third that of steel, aluminum was formed and joined into complex shapes using extruded, die-cast, and sheet materials. Honda has extensive experience in the use of aluminum. The first mass-produced car with an all-aluminum body was the Acura NSX, introduced in 1990. Honda has continued to research and develop the use of aluminum, leading to the introduction of a new lightweight structure for the Insight that offers high rigidity and advanced safety performance. Joints where frame elements come together benefit from the ability of single pieces of die-cast elements to be formed into complex shapes. This enables more rigid connection of extruded pieces using fewer parts. Honda's G-force control technology optimizes each component of the body to best manage impact forces. To help protect the passenger cabin, the cabin floor structure is composed of large section extruded elements and highly rigid joints to form a strong foundation that only minimally deforms upon impact. The passenger cabin is surrounded by a frame structure, making the best use of extruded material characteristics, controlling impact forces by efficiently absorbing and dispersing the energy of front, rear, and side impacts. In a frontal collision, a hexagonal cross-section front-side frame structure provides efficient impact energy absorption. Upon initial impact, it folds like an accordion. The remaining energy of the impact is then redirected as the rear section of the front-side frame bends upward. The rear floor frame is also designed to effectively absorb the impact energy of a rear collision. Side impact energy is dispersed by the highly rigid side pillars, side sills, and crossmembers. The Insight's aluminum frame and body is designed to meet Honda's in-house safety targets, calling for 35 mph full frontal impact, 40 mph offset frontal impact, 38 mph side, and 35 mph rear crash tests. The Insight also meets the new federal head impact safety standard, which goes into effect in 2003. Main body panels, including the roof, doors, and hood, are aluminum. The front fenders and rear wheel skirts are lightweight plastic. As a result, the Insight weighs 47% less than the steel-bodied Civic hatchback, which is comparable in size. The Insight also possesses 13% greater bending rigidity and 38% greater torsional rigidity. The Insight not only features a lightweight body with world-class safety performance, it also has a 0.25 coefficient of drag, one of the lowest of any mass-produced automobile sold in the world. Aerodynamic design features include its rounded nose, low height, tapered body, front air dam, rear wheel skirts, and plastic undercar cover to create a smooth, flat underbody. The suspension of the Honda Insight features McPherson strut front suspension and torsion beam rear suspension. Lightweight forged aluminum is used for the front lower arms and steering knuckle. The Honda Insight employs electronic power steering, a design that reduces power loss, weighs less, improves responsiveness, and is more compact to fit in a smaller engine compartment. Lightweight aluminum alloy wheels feature an aerodynamic disc-shaped design. Low rolling resistance all-season 14-inch tires also aid fuel economy while maintaining exceptional road-holding performance. The front disc brakes use ventilated discs with aluminum calipers for weight saving. The Insight is equipped with anti-lock brakes. The ABS control unit is integrated with the modulator for added weight savings. The driver's cockpit reflects the high-tech nature of the new Insight. It provides comfortable personal space for the driver. The seating and control layout is designed to enhance the driver's interaction with the vehicle. High-back bucket seats are extremely supportive and feature high-tech patterns and textures. Complete digital instrumentation provides easy-to-read instant access to the performance and operating condition of the vehicle. The electronic instrument display is divided into 3 areas. To the driver's left is the gasoline engine status section, showing engine RPM and coolant temperature. Directly in front of the driver is the digital speed readout and fuel consumption display. One displays instant fuel economy, while 2 resettable trip odometers also display trip fuel economy. In addition, the vehicle records and displays lifetime fuel economy. To the right of the driver, the IMA system indicators provide information on the action of the integrated motor assist system and prompt the driver to select shift points most beneficial to fuel economy. The charge assist indicator shows whether the IMA is providing motor assist or is recharging the IMA battery. The battery state of charge is also displayed. Additional indicators provide information on fuel level and service warnings on the engine, IMA, SRS, and other systems. The Honda Insight includes a complete list of standard features, including power windows with auto-down driver's feature, power door locks, remote keyless entry system, Honda's ignition immobilizer system, which prevents starting if the electronic code transmitted by the key does not match the code expected by the vehicle, AM/FM stereo cassette, numerous storage compartments, beverage holders, and passenger seatback pocket. The Insight also features available automatic air conditioning with large, easy-to-use electrically operated controls and a micron air filtration system. Driver and passenger are protected with dual airbags, 3-point seat belts with pre-tensioners and load limiters, and fixed head restraints. The cargo area is easily accessible through the rear hatch. The Space Saver spare tire is housed under the hidden storage well. Fully featured, comfortable, and rewarding to drive, the Honda Insight takes automotive state-of-the-art to a new frontier. More than 300 new patents apply to the Insight, 150 on the IMA system alone. Its breakthrough technology shows the way to greater conservation of natural resources, reduced emissions, and greenhouse gas reduction. Honda has also developed a new aluminum upgrade recycling technology as part of the development of the Insight. Up to now, it has been impossible to recycle cast aluminum into extruded materials. With Honda's new technology, it is now possible to recycle die-cast materials, such as engine blocks, into extruded aluminum shapes, such as the steering column hanger beam on the Insight. The Honda Insight is the expression of Honda's commitment to society and the automobile. As the company's founder, Soichiro Honda, said, "Our approach is to create products that balance our customers' desire for fun and performance with the needs of society." That is the new Honda Insight.